So with that, I'd like to get into the presentation and just to give a little bit of a heads up here so that I set the expectations right. After we put together this presentation, we noticed that there is a vast area of coverage of topics here. It will not be a completely deep dive into all these topics, but some will be at a high level since it's only a 45-minute session. Some of them will be at a high level, and there are a few topics here which, in which we'll be doing a deep dive. So I just want to set the expectations right so that we have our mindset accordingly. So let's not expect everything to be at a high level. I'll keep you posted as we go further. I'll just spend a few minutes, quick over, since there's a huge list of topics, just to break it down and make it easy. I put this single slide together that captures everything that we're going to discuss today. We'll start with a little bit of introduction to the industry and some terminologies there so that, when I say 3G, 4G, 5G in the middle of the lecture, it'll make sense to you, so that I just give a brief introduction on that. And once we are set up with that, we can get into the actual need for network planning and review, what are the different layers in network planning, how it's done, from start to the end at a high level. Okay. And then we'll get into the types of networks and ultimately into the access layer and backhaul planning, as you can see the topics there. So those two topics, layer planning and the backhaul planning, they will be the core topics of this webinar. Ultimately, all the introduction in the beginning is just helping us to get there. And once we get there, we're going to have a deep dive on both these topics. And I think that'll be the key takeaway out of this webinar, where I'd like everyone to learn something on access planning and backhaul planning. And I think that'll give you a clean grasp on all the fundamentals here. And it'll definitely give you a thorough understanding of network planning in general. And towards the end, we'll touch upon the network planning tools as such and field survey that are generally conducted. And I think without the tools, it'll just be a theory. So it's good to touch upon the tools and see how industry operates and what type of tools are required to do a job in this type of an industry. And then a little bit, I wanted to touch on the business case evaluation as well, because this is really an important piece. Everything we study in this webinar altogether, comes up as one item in the business case evaluation, and it all feeds into that go into investment on planning any technology. So that's a critical piece, and I just wanted to touch upon it before ending. And towards the end, I'd like to dedicate at least 10 minutes on the employment areas and research areas that are pertaining to this field of network planning. So with that, I think I've given you an overview of how the session is going to look like, so that our thinking process is oriented in that way. So let's get started with a little bit of history. So as we all know, telecom as such, we call it, it started when Graham Bell invented telephone in the 1876, 1877, around that period. And after 100 years or so, we started the cellular communication technology. We just started with it. There was the invention happened in around 1970s, and then 1980s, it got industrialized. And we started, if you were born before, you might have seen really big handheld cell phones that are there, that are heavy, that are completely analog. There was no digital setting inside it. It was completely analog, made up of circuit boards, transistors, capacitors, etc., like heavy circuit boards. That's what we call as the 1G system. That was the very first generation of the cellular phones, making this biggest move from the landline phones to the cell phones. But as you might have been aware of that, there is no SMS. Since it's not digital, it cannot be non-real time. You cannot send something and people can take it at a different time. It has to be a live communication. It's like a live FM radio, right? It's completely analog. There's no security in it. Anybody can tune to your frequency and listen to it. Of course, since it was not, the hardware was not optimized, low battery life, low bandwidth, it was all limited in the first generation. And then that's when we moved on to the second generation, where we started introducing digital technologies in there. Now the switching system, that manufacturing of switch was critical at that time, and it was gaining momentum. And with that, coupled in with the analog cell phones that were already there, we came up with this digital switching technology, which enabled a lot of mobility, and a lot of SMS started, messaging started getting into the cellular communication arena. That's what, there is a further breakdown of 2G, 2.5G, and 2.7G. We don't have to get into that many details, but just as a highlight, and I'm just saying that's overall what 2G is. And from there on, we went into 3G. And now by 3G, I mean, we are talking about around 2009, 2010, that's the period where it started. So the biggest initiator of 3G was the first, I believe it's the first generation of iPhone, which had a front-facing camera. And I think the front-facing camera is the only one that enables a video calling, because otherwise the cell phones before that only had one camera on the backside. That did not enable a video calling. That was more for pictures. But 3G with the higher throughputs, it was allowing the video calling capability, and that put a front of the phones around 2010s. Such phones were being manufactured, and they were in business. But as you can imagine, when this type of a technology arrives, everybody starts using it, and there is more pressure on the bandwidth. What is the spectrum that's allowed? How much data rate you can use? Once everybody starts using it, it gets a crowded space. And of course, devices were getting expensive. We need better infrastructure. So by infrastructure, I mean the cell towers and their arrangement in an optimized way so that we can handle the traffic inflow and outflow in the network. And now that leads us to 4G, where 4G is pretty much an evolved version of 3G with all this video calling, but now we have a HD version of videos, which means it requires more throughput. The channel, the pipe from the cell phone, to the other cell tower, and then within the cell towers need to be made more thicker so that it can, send back and forth HD or high quality data in there, or basically we can say high bandwidth communication was getting into 4G. What created 4G. And of course, there's more expensive devices and more traffic as the population growth and the population density and economic development is there. People start using more mobile phones. There is more communication going on. Now, again, it puts us, more stress on the bandwidth. See, as you see, in every generation, from one generation to the other, we always have an issue with the bandwidth. As we evolve the technology, the demand goes higher, the need also goes higher, and we have to serve the next set of new demand that's coming. And that's where we are heading towards 5G. As with 5G, you might be aware that it's taking into account V2X-COM. So what V2X-COM is vehicle to X, so vehicle to cell phone, vehicle to cell tower, or vehicle to anywhere. Connecting all the vehicles, given the electric vehicles that we are going to be having soon, connecting them is going to be a challenge, and there's going to be a lot of load on the cell towers. Having too many devices. There are so many wearable sensors nowadays, like watches, digital watches we have it these days. Biometric devices that monitor our health, they all need to be connected in one way or the other. Ultimately, even a toaster would be connected. But having them, definitely puts a lot of load on the network, and 5G is addressing those issues and taking it to the next level. So that's a quick introduction from 1G through 5G, and 4G is where the terminology LTE comes into picture. There was the other term, long-term evolution, because it was evolving at a much longer pace. So sometimes it's alternatively called as 4G or even 3G LTE towards 3.7, 5G, and 4G. So I believe that's a quick introduction, to the evolution of the industry from a cellular or a telecom perspective. Now, switching on to Wi-Fi industry, strictly speaking, this does not come in the telecom side, but it's an indoor usage wireless system. That's about it. It's not a telecom, strictly speaking, but still, we can put it in the same framework and then still look at it as a comparative analysis. What is Wi-Fi and how the infrastructure in Wi-Fi differs from that in the cellular communication. Of course, Wi-Fi uses a different band. We call it the unlicensed band at 2.4 gigahertz. And nowadays we also have 5.8 gigahertz being used. So Wi-Fi has been evolving for a while, and a standards body we call it IEEE standards body has been leading the evolution. Standards are pretty important here. It's like in layman terms, it's like the power socket and the plug. They always have to match, right? They have to be designed to certain standards. So similarly, if your laptop is using Wi-Fi, it has to match with the router. So there's something called compatibility, and IEEE ensured, right from the beginning, there's always compatibility with the devices that are currently existing versus the new technology that's upcoming. So it started with 802.11b. 802.11 is a general framework of Wi-Fi for WLAN, as they call it. 11b was the first 11 put providing standard there. And of course, it had its own throughput limitations. As video calling and everything was evolving, we moved to 11a, which took it up to 54 Mbps. It started using a technology called OFDM. It's a modulation technique. And it also switched to 5.8 gigahertz. And then we had 11G. Now it addressed it took the same 11A technology, but it supplying it to both 2.4 gigahertz and 5.8 gigahertz. And then we had 11N that brings in MIMO, which is multiple input, multiple output. And that's basically nothing but having multiple antennas. So you might have seen routers with so many antennas nowadays. They are basically 11N router, which has multiple antenna streams. So it's like having multiple data streams parallelly streaming. And that can take it up to 600 Mbps. And in the future, we still have some of the 11AX devices that are being in production now and that are available in the market that can support much higher bandwidth, efficient frame construction. And we also have some this upcoming, some companies are working on them, which uses 60 gigahertz frequency, which is the unlicensed band in the millimeter wave. And that's also upcoming. So these are just, so this is just an overview of how the Wi-Fi technology has been evolving. So now that we have this introduction on Wi-Fi and the cellular standards, I think we can get into the core piece here, which is the network planning, or what is basically the need for network planning. Okay, so I just put this slide together just to take you from the ideation to a deployment. What is the workflow there, and where exactly does network planning fit into this business? So we start with a business need. So any company, let's say it could be Geo in India, or Airtel, or AT&T in the US. They start with a need. They identify something called as AOI. What is AOI? Is area of interest. That's it. So you have a certain area of interest. Let's say it can be some region somewhere in rural America or in India that is not connected. That can be your area of interest. And then they start from business evaluation need. How many people are there? How many people will subscribe to our network? How much can we charge them? And how much will it cost us to build the network? And they go from there. That's like a business need evaluation for the company. And then with that, the next step would be a technology selection. Having that business need in mind, what kind of technology should we offer it there? So if it's a completely rural area where people cannot afford any 5G phones, then there's no point in bringing in a 5G cellular technology to that area, right? So it is very much area dependent, and what is the demand there, what kind of service is required. So based on that, a technology is selected. And once these two decisions are made, again, these are soft decisions, they'll always go back to it and change it. Once these decisions are made, they do something called as the site survey. So what site survey means is it's as simple as a bunch of engineers going to the field, surveying the field, looking what type of terrain it is. If it's mountainous, the signal could be, it'll be a little hard to get the signal everywhere. There is a shadowing that's coming because of the mountains. Or if there are existing cell towers there, they can use that. The site survey will answer all those questions. And with that survey, they get into this important phase called network planning. And what happens in network planning is basically taking all the site survey data, we assess and see what kind of network that can be deployed there. And if it is deployed, what kind of throughputs or what kind of data rates can the users be offered. And once we have some sort of planning, what we do after that is called parametric evaluation. And what this means is we modify certain parameters, such as, let's say, placement of towers. What if we change the height of the towers? What if we change the frequency of communication? How the overall plan changes. So it's a little bit of back and forth between network planning and parametric evaluation. And then finally, we go back to the business model, feed all the data that we studied so far from these analysis, feed it into the model again, evaluate it again. And if it still makes sense, towards the deployment. So that's the ideation to deployment workflow. And now I believe you are seeing where exactly the network planning fits into this. And up next, I'd like to double click on this network planning block and see what's inside it. So what exactly happens inside this piece and how it's helpful for closing the overall business case. So starting from the site survey, there are a few items that come out of it, which I mentioned, but let me give some more details here. So the first thing is we look for nearest presence of connectivity. What this means is when you're going to deploy it in some area that is not connected or that is having some lower than needed connectivity, we look for some existing connections there. We have to find a nearby city that has a good connection, and we can sort of route something from that city to this particular place that is our area of interest. That's what we mean by nearest presence of connectivity, and they are critical in terms of planning inputs. And then understand the area of coverage, how wide it is, how many. This will give us an idea of how many cell towers are required, what is the budget that is required by the company to invest in it. And then taking help of the existing infrastructure. There could be towers already there being owned by some landlords. in that locality, and they can rent the towers, and interacting with them and identifying what is the rent looking like. That is also an important input to this planning. And the population density, which definitely is correlated with the throughput demand in that location. And if it's very dense location, the network has to be strong enough to serve a higher demand. And existing networks are also important to look at. This is different from the existing infrastructure point that I made earlier. Existing networks refer to the networks that are already in business in that location. That's possible. Sometimes we have to go on top of them. We have to make sure the band or the frequency band that we're using is overlapping with them so that we don't have any interference issues. We have to make sure that, how do we get the customers that they already have and into this new network that we're building in? Or if the customers are already there, why would they come into this network? So that's a little bit of analysis there from a business strategy perspective. Finally, another technical piece here is the terrain and vegetation types. If there are a lot of trees in the area, if it's a forest region, then there's going to be a lot of loss in your signal quality, which needs to be considered in the in the network planning area. So again, it's not limited to these items. There are much more that can be learned during the site survey, and every site is different. There will be new things learned, and the overall link network planning procedure is refined based on that. So here is a typical procedure that I've highlighted here. It starts with what is called as link budget analysis. And what this means is basically a capacity analysis. You have a cell tower and you have a cell phone. What is the capacity that can go 2 points? That's pretty much what a link budget analysis is. But it can be extended from one cell tower to multiple cell phones. There could be thousands of cell phones connecting to one cell tower. And now we have a question mark of whether this is possible or not. Can the tower meet that demand? And at what distance? What is the cell radius? So ultimately the link budget leads to the cell radius. When you have a tower, how far the reach of the tower can be. That's what the range or cell radii means. In case of Wi-Fi router, how far the range of the router is. Typically routers go up to 100 or even 150 meters long. Anything more than that, you'll lose the signal connection to your router, right? So the link budget analysis also applies to a router as well. So it can be applied to any technology. It's basically a communication system technique that is there to identify the cell range and based on a certain capacity requirement. And now based on the cell range and the cell radii, we can do the site placement. I'll give you a quick demo of what a site placement is. So in terms of cellular communication, it's like, where do you place the cell site? So you build the towers in an optimal way so that you can get your maximum coverage. And once we have the site placement, then we have to look at the interference assessment, which means one site can interfere with another site, and that could cause interference and ultimately degrade your throughput. Now, this leads to sectorization. As a solution to interference mitigation, we need to sectorize. We'll get into that quickly to see what exactly sectorization is. And sector coloring is related to that. We'll get into that in a bit. And ultimately, we go to something more important called KPI evaluation. So KPI is key performance indexes, which means in case of LTE, it will be like the final throughput that you get, how many Mbps are you able to serve, or it can be much more technical, like it can be much more scientific, like RSRP, receive signal radio power, something like that. Or it can be RSSI, receive signal strength indicator, which will be like some level of dBm values, say minus 65 or minus 75 dBm. It's basically the signal power that is received. So that can be an evaluation metric. It's a nice platform to conduct an optimization problem there. We can formulate it like an optimization problem, which means there are so many possibilities of selecting the network's site locations. We can select the site frequencies, the sectors, the colors of the sectors in such a way that you get the best possible coverage and capacity that is needed. So that's what I mean by network optimization, which is a very complex piece. Sometimes it requires all the inputs that we have discussed so far in order for it to converge. Now, a quick demo on this diagram that I was just explaining. I understand it's a little bit complicated here, so that's why I just wanted to double click on it again, and let's review it again with an example now, okay? So let's take this area. I just randomly picked an area here in India, and we can focus and see how we can connect a certain region, how the network planning starts here, okay? So let's say we pick somewhere around here, if you can see my cursor. Let's say this is your potential cell location. And what we do is that first thing is after the site survey, we'll right away get into the link budget analysis, and we'll identify the cell radius. So which means I've placed the tower somewhere here, and this is the cell coverage radius. It can be a couple of kilometers, not more than that. It depends on the height of the tower, of course. So once we have a cell radius, again, we can change the height of the tower, or depending on the buildings that are blocking, this can always change. It can shrink or it can become bigger slightly. So this is what we call a cell placement. So now we have placed a cell based on the radii that we have. And now the next step is interference assessment. So once we have here, there are so many users that can interfere within each other in this cell. So what we can do is something called sectorization. So what this means is cutting the cell into multiple, like a triangle, multiple pieces, such that one triangle does not interfere with the other. So the antennas are assigned in such a way, the roll-off factor is set up in a way that it is not interfering with the next sector. So there are three sectors here, just colored them for visual purposes here, just like green, red, and orange. They are different sectors. So any user here will not interfere with any user in this one, because this sector, the antennas here are not covering the users beyond this angle. So they have an angle of coverage and they try to stick within that angle of coverage. Of course, you can always ask a question, what if a user gets stuck somewhere in the middle of the sectors? There is always a problem there when they're in the middle of the sectors. That's why when we drive, sometimes we lose the signal because we are probably traveling within the sectors. It happens, but they try to optimize it the best so that your these shadowed region falls in areas that are not so widely used. Maybe there are no roads or there are no buildings there. They try to rotate these sectors in such a way that the coverage is optimized for the benefit of the users there. So that's what I mean by sectorization. And the next step is placing multiple cells in the area. So you can go about and place, let's say in this example, I've shown 3 cells. And once you place them, now you can see that one cell will start interfering with the other. So it's better to color them. By coloring, I mean assigning a slightly different frequency to these sectors, such a way that the same colors do not overlap. So now you can see the green frequency is overlapping with the red frequency here. So placing these cells in such a way that you have these triangles arranged in such a way that there is no interference among these cells. So that's what I mean by sector coloring. And once we do this, we can look at the KPIs that are being evaluated here for the users that are in these cells and see how their interference levels are, how their receiver signal strength levels are. And then we can go about the network optimization. So network optimization is nothing but placing these 3 circles in such a way. There could be better way than what I'm showing. So there are tools to identify the optimal placement of these 3 circles, way that you can optimize your coverage and meet your capacity needs. So this looks a little complicated, but I think I made this diagram only to explain what network hierarchy is, just in very simple terms. So we can look at it like end users to end users, and we'll see how the connection happens here. So end users, we can call them, put them in a white square that belong to one office or home location, and then another bunch that's located somewhere else. Now, let's say if it's a cellular technology, they're all connected to one cell tower, and this tower talks to other towers. Sorry, let me go back. So, yeah, this tower talks to other towers, and from those towers, we have a fiber link that can probably take it all the way into an underwater fiber link if it's an overseas communication, or it can go through a satellite. It can latch onto a satellite link and then go through a satellite link and then again come back to a fiber link and then to other towers and then to another cell tower, which again connects to the end users. That's about it. So these blue shaded regions are wireless. It should be wireless because they are access networks, right? That's what we mean by access networks. The users are trying to access the cellular service here at both these ends. And everything else comes under what is called as a backhaul network. Or we can also call it as front haul, and then the backhaul connection as the core connections that happen in the backend, which we don't see. So as users, we are only in this light blue region that connects to a cell tower or a Wi-Fi router. So now, having explained that hierarchy, I can now easily categorize it. The network planning can be for backhaul purposes separately, or it can be for front haul, the access network. So backhaul, it could be a fiber network or it could be a wireless backhaul. We have these huge antennas on top of buildings that you can see in urban areas that are basically backhaul wireless links. So one network, one building connecting to another building. Instead of connecting a fiber between 2 buildings, we can connect these backhaul wireless links. Or if it's really a long distance communication from one country to the other, it can be a satellite link that has to be planned appropriately so that the backhaul network is complete. So again, it may not be only fiber, it can be a combination of 2 or 3 of them. Whereas access on the other side, it gets a little bit more complicated than the backhaul because access is more wireless. There's one cell tower dealing with thousands of users. That's much more complicated to design and analyze. Excuse me. On the Wi-Fi side, it's much simpler, but we don't have too many users per device, but there will be too many devices per apartment, say, for example. And then planning the placement of these routers is critical. Otherwise, there will be interference because they're all using the same frequency and they tend to interfere a lot. That's why when, and everybody's using the Wi-Fi at the same time, we used to have a lot of Wi-Fi issues because of the interference. So I believe I'm making it clear on access versus backhaul, because we're going to have two different design strategies, especially the network planning strategies for access and backhaul.